today we now be doing question 3 of 2017. Today we're now gonna do some equations. Now we're talking. Sadly, this isn't calculus, but we are now going to introduce a very clever trick called the inverse function. On the same axis, labeling each curve clearly, set y equals fkx. This is boring, but we'll do it anyway since it's part of the question. So, this is k equals 1. Then, this equals to k equals to 2. And this, hold on, drawing, here we come. Bad drawing skills. This is k. What? K is 3. So, between the 2 points of intersection, the curves y equals to fkx includes several regions. What's the area of the region? Because y fkx, y fk plus 1x. Because we are now going to do some integration. What is integration? It's basically finding the area under the curve. And how do we do that? We basically reverse the differentiation. So the power rule on differentiation is subtract 1 to the power and divide by the original power. Now, the power rule on integration is to add the power and divide by the new power you've got. But we are now going to do a trick. We are now going to flip this graph over so that we flipped it over. And so what we basically have done is we've taken the inverse of all of these graphs. So this is x, this is x squared, and this is x cubed, and this will make all your integrations easier. So this means that the area between fk and fk plus 1 is the same as the area between x to the power k plus 1 minus xk. So we're now going to calculate that. And here we are now going to see the power law for integration. 1 over k plus 2 xk plus 2 minus 1 over k plus 1 xk plus 1. Oh, I must have forgotten it's supposed to be minus here and plus here, since the graph of k plus 1 is a bit more flat than xk. So we done this equals to, and then we substitute 1. We had to put our 1 here and our 0 here, notation. Equals to 1 over k plus 1 minus 1 over k plus 2 equals to, and then we are now going to write this. Why? This is made possible with the arithmetic of fractions. So you can work this out yourself, but the denominator is actually called a pronic number, which is twice the triangular number. So what? Then verify that the area of the region between f1 and f2 is 1 over 6. So we're going to substitute at 1. 1 over 1 plus 1, 1 plus 2 equals to 1 over 6. There. Let C be a constant. Find the x coordinates on point intersection when the line yc f1x, yc f2x. So obviously, y equals to c. So f equals to 1, f equals to 2. Y equals to c. And x equals to c, because we just made the inverse function, and now this we use the inverse function to our advantage now, because we don't have to do any square roots. In fact, the answer doesn't involve any square roots at all, because y equals to c inverse function is x over c, x equals c, and then this x, this old x will be x c squared. So the constant c is chosen such that the line yc divided by a region between line y's f1x and f2x into two regions of equal area c. Now that's where we use our integration powers. So constant c is chosen. So this means 0c x minus x squared dx equals to 112. So half x squared minus 1/3 x cubed c0 equals to 1 over 12. So this means half c squared minus 1/3 c cubed equals to 1/12. And we rearrange this equation, it becomes 4c cubed minus 6c squared plus 1 equals to 0. Now, what we're going to do is solve using Tatakia's cubic formula. No lah, just joking. Now what we're going to do is that we're going to substitute x equals to 2c. Why? We're gonna see later. Yep. So this means which means that x cubed over 2 minus x squared minus 3x squared over 2 plus 1 equals to 0. Yay! X cubed minus 3x squared plus 2 equals to 0. Solving this will give you, by inspection, x equals to 1. Then therefore, c equals to half. There! Miraculous, isn't it? The power of calculus. We can harness the power of calculus and find some amazing properties, like when c is half, the area is half, and vice versa. And now let's flip over this graph so that the Oxford MAT doesn't get mad. Fixed. There. See you. Bye.